This is my biofuel video project. And the biofuel I decided to choose was the algae-based biofuel, a type of renewable fuel that can convert oils and other fuels into energy through the process of photosynthesis and cellular respiration. For cultivation slash growth, that's the first thing that's needed for this process of producing it. We have open ponds and closed photobioreactors, which are two ways of going about it. For open ponds, these are small, shallow channels of water that house algae for photosynthesis. Closed photobioreactors are transparent tanks that provide a controlled environment for the algae to grow. They do provide the necessary components for photosynthesis, as open ponds do, but also provides controlled temperatures, controlled pH, and light intensity levels. So for the phases of production, we already covered growth, but for harvest, there's filtration, which is filtrating algae from water, centrifugation, which is circulating the water to separate the algae, and flocculation, using chemicals to bring the algae contents together. For extraction, there's three different types, but I'll go through one, which is hydrocarbon fuel, which is using hydrothermal liquefaction, which converts wet algae biomass into fuel. For the last step is refinement. From the extraction, the biofuel created from algae is purified using gasoline or diesel. So these are the production processes. This shows the first step, and the second step, the third step, and the fourth step. On the left, it shows the open ponds, and on the right shows the closed photobioreactors. The development status is that algae-based biofuel is still in development. The government, universities, and research institutes are trying to create advanced methods to extract oils and purify the algae into biofuel through lower cost procedures. Companies such as Viridos and Sapphire Energy also currently implement applications for aviation mechanics and energy production. And in general, biofuel is not widely available, especially in commercial areas. For environmental consideration, impact is mostly positive because obviously the algae-based biofuel goes through photosynthesis, which means it absorbs CO2, therefore decreasing greenhouse gas emissions. Well, there is one process where it could possibly lead to more emissions than decrease of emissions, which is the high use of water channels and nutrients, which could lead to fertilizer emissions, depending on the process used to grow and harvest the algae. The economic impact for algae-based biofuel is high production costs due to maintenance process, including photobioreactors and extraction methods. The price also ranges, but it is higher. For standard diesel, $3 to $4, while for algae-based biofuels, $5 to $20. For alternative applications for algae-based biofuel for the future in the economy, we use this for pigments, for cosmetics, proteins for animals, oils, and specialty chemicals. There's also the potential for job creation, which is creating new jobs in farming, biotechnology, engineering, and fuel processing. For the efforts for the next steps for our actual analysis and recommendation, I believe that we can use the news and the government to properly advance our advocacy for algae-based biofuel, using supplementary news outlets to basically promote the reduce in GHG emissions and increasing energy efficiency within biotechnology. We can also alleviate the polarized view of global warming, which can benefit both parties, which are Republicans and Democrats, through increasing nationalism by using algae-based biofuel as a way to reduce our reliance on imported oil, while us using algae-based biofuel can also decrease greenhouse gas emissions, which will also be satisfactory for Democrats. For analysis and recommendation, basically, the only problem right now, and I would say there's other problems, but the biggest problem is the cost to produce it. I believe that in order to decrease costs, we must combine experimental initiatives between companies so they're not using all the resources for the same application, and we're being more efficient with our processes. I do believe that resource dissemination can also be possible using government intervention. And I also believe that our application, farther from just pure experimentation, can be used towards commercialization of the biofuel so it can benefit the public as well. This is the data supporting analysis. On the left, it just shows the difference between fossil fuel and algae-based fuel for emission of CO2. And on the second graph, it just shows the increase in biofuels, especially for algae-based as well over the years. For the plan of action, like I said, government intervention is going to be needed. I do believe that we should appeal to policymakers to increase application of algae-based biofuel for the both reasons, decreasing greenhouse gas emissions and reducing reliance on imported oil. I also believe that we can use federal subsidies and tax incentives to decrease cost of production as well. For commercialization, we should appeal to multiple energy and transportation companies to increase its application to supply chain transportation, aviation, and public transit systems. For research, we should create a nonprofit initiative that combines universities, companies, and research institutes to work together so that they're using the resources collectively to improve algae-based biofuel productivity. And like I said before, with news outlets, we can use those news outlets to appeal to the public and increase public support for political avenues. These are some of my citations, and thank you so much for listening.